Hey everyone, this is Abhinav Chandra, welcoming you all to my YouTube channel. Today we are continuing with our TCS NQT examination prep. Today we are going to solve this question. It is quite simple, but it is asked in the examination again and again. We can solve this question in two ways, both using loops. So let's solve it. So the question is, given an array and an element, we have to find the index of the given element inside the array. So let's say we are given an array of this ARR and we are given a number. In this case, this is 4. We have to search the number and return the index at which it is present inside the array. So let's say here the number 4 is present at third index. So its output will be 3. So how can we solve it? So the easiest solution will be to loop through all the elements inside the array and return the index at which we find 4. It is very simple. So let's implement this. First of all, we will copy this array, paste it here. Now we have to copy this part, num is equals to 4. Now we are going to define our function. We'll name this find. We are going to pass the argument ARR and end and whatever. So what are we doing here? We are looping through the elements using the index. So for I in range, we are utilizing the length function to determine how many times the loop is supposed to run. So now we are going to write the condition for this question. So now our code has been completed. Let's run this code. We got the answer 3, which was the supposed out. We got the answer 3 and it was our expected output. So we got the answer. Here what we have done, we are checking if the array at I, which means the element at the index I, is same as the element we are supposed to find. If that is the case, then we are going to return the index. It is very simple. But here the time complexity is O of n. We can improve it further using the two pointers approach. In last video we have seen what is two pointers approach. Now we are going to implement it in this question so that the time complexity reduces to, at the worst case, n by 2. So for the two pointers approach, we have to create 2 pointers, one pointing toward the first element of the array and another toward the last element of the array. So let's create those. So now we are going to run a while loop. So what we are doing here is we are running a while loop with the condition of first being lesser than the last, and we are going to first is equal to first plus 1. So in every iteration the first will increment by 1 and the last will decrement by 1, and we again check this condition if it is true or not. If it is true, then only the code inside this while loop will run. If not, then the execution will stop. Now the inner part is actually going to be same as the last one. So what we are doing here is we are checking if the element inside an array at index first this one is equals to num, then we are going to return the index which is first, which is stored in the variable first. If that is not the case, we are checking for the last one also. If the element at index last inside the array is equal to num, if that is true, then we are going to return the index last. Okay, and if both of them are incorrect, then we are going to increment the first to 1 and decrement the last to -1. Let's run this code and find out. So look, the output is none, even though we know 4 is present inside the list, but still we are getting no returns from the define function. So why is that? So what is happening is the first index is right now here at 3 and the last index is right now at 5. What is happening is the condition was first should be less than last. That is true. 3, this index is less than this index, but at this index the both first and the last will be same, will become same, because it will increment by 1. So 3, the first index when it was 3, at 3 it will increment and come at 4, and the last index which was at 5 will decrement and come at 4. All of a sudden both the first and the last variable is pointing towards the same element, but we haven't write the code where first and element we haven't write the condition where first and last become same. It will not reach this at the middle point, middle junction, and does not return any value. So to solve this we only require to add an equal. So now the condition changes. Earlier the condition was if first is less than last. Now the condition is if first is less than or equal to last. So that means now the first and the last can be equal and still run this loop. So let's run this code again. Now we got the right answer 3. By doing that we have reduced the time complexity from O of n to O of n by 2. So this one is more optimized. So let's check out the second question. So this is the second question. So the question is frequency count of an element inside an array. We are given an array of size n and we have to return all the distinct elements and the number of times they have been repeated inside the array. So for example, we are supposed to grab all the distinct element like 1, 5, 7, 3, all the distinct element, and give out the frequency of how many times they have occurred in the array. So for example, 1 has occurred twice. 1, here it is 1. So it has occurred twice. So we have to return 1 and 2. For 5 has occurred 3 times inside the array. So we are returning 5 and 3. 7 has occurred once, 3 has occurred once. So we have to return this thing. Let's write the code. First we'll copy the array. So now the brute force approach will be, we will run a loop through all the elements inside the array, and then on another loop for each element searching inside the array. But it will be very, but it will create a huge time complexity. So we don't want that. Instead, we can use the data type of dictionary to solve this question. So what is dictionary? Dictionary store the data as a key value pair. Here we can see the key is 1 and the value is 2. All of this can be written inside a dictionary as a key value pair. So let's define the dictionary. Let's name the variable answer. We can define the dictionary using this curly braces. Now an empty dictionary has now been created. So now we are going to loop through all the elements inside the array. So now we are going to check if I is I is inside answer. If I is inside answer. If it is inside answer, we are going to do something else. We have defined two conditions now. One is if I is inside answer, and the second one is if I is not inside answer. So we will write the else condition first. Now, if I is not inside an answer dictionary, right now which is empty, which is true, because right now answer dictionary is empty. So what we are going to do is we are going to add I. How can we add it? Answer at I is equals to, we are going to initialize it with 1. So when we first run the loop, we got the value I as 1. 1 was not inside the answer dictionary, so we are adding 1, and with that, how many times we have seen 1 inside this dictionary right now? We have only seen 1 time, because right now we are at this index only. We have to travel these all these indexes. Now the loop will run once more, and we will reach first index, and the I value will become 5. Again, 5 is not inside the answer, so this portion of the if loop will run, and again we are going to add 5 together with its frequency of 1. Now two elements has already been added. For the third iteration, the I will become 1 again. Now if I in answer, now this condition will become true, because 1 is already inside answer dictionary, and it has the frequency of 1 right now. So what we are going to do is we are going to capture the frequency value of 1 and increment it with 1. So it will become 2, because we have traveled this far in the array, and we have seen 2 ones. So frequency will become 2. So what we can do is answer at I equals to. Now this statement will mean that here the frequency will change from 1 to 2. Now this will happen again and again for all the elements inside the array. Print answer. So let's run this code. We have got the answer. 1 is there in the array and its frequency is 2. Here it is. Now 5 is having a frequency of 3. 5 is having a frequency of 3. 7 is having a frequency of 1. 7 is having a frequency of 1. 3 is having a frequency of 1. 3 is having a frequency of 1. So now we have got the answer. So why we have used this dictionary? Dictionary has a specific property which makes it very useful in the DSA. So let's suppose we have, let's run this code again. We have this dictionary. Let's suppose we have this dictionary. Let's suppose we have this dictionary. Now, if we have to find inside an array, the time complexity will be higher compared to dictionary. Why? Array uses memory in such a way that if we want to find the last element of the array, we have to travel through all the previous elements inside the array. That is not the case in the dictionary. If we want to find 3, then we can directly find 3 in just one instance. While in array, we have to go through all the previous elements and then we will find the last one. This is not the case in the dictionary. So the time complexity of search in dictionary is O of 1. So it takes a constant amount of time to search no matter what the length of the data is. That's why we have used in this scenario. So that's it for today. We will meet tomorrow.